If you've ever seen somebody shoot a gun, then you might have seen that the person actually the gun actually pushes behind when it fires the bullet. So that is known as a recoil, and that is the reason why, if you sometime learn shooting, you are instructed to keep the gun against the shoulder so that you don't get hurt, or else the impact of the recoil may hit the gun to your shoulder and injure you. So to avoid that, you're instructed that way. And let us understand the physics behind recoiling, and how can you calculate the velocity of recoil, or at what speed would the gun recoil for any particular shot. So here I have a toy gun. This is a toy gun here, and let me use this to explain you how we can calculate the velocity of recoil. So let's say this gun weighs maybe 4 kgs. So 4 kg is the mass of this gun here, and let's say I have a bullet inside this which weighs let's say, for this question, 1 kg. Obviously we don't have that, we don't have bullets of 1 kg mass, but just for the sake of this example, let's suppose we have a bullet of that mass, just to simplify the maths. And now let us suppose we wish to find the velocity of recoil. So in this situation we will apply the law of conservation of momentum. Let's see how we do that. So first of all, to apply the law of conservation of momentum, we need to know the total momentum before the collision. In this case, what is colliding? Well, when I press the trigger of the button, in this case obviously this is colliding with this, but in real guns there is some gunpowder that is being ignited, and when the gunpowder ignites and expands, that is what propels the bullet forward. Obviously that is not happening in this case, and yeah, that is not a proper collision, but that is the beauty of law of conservation of momentum. Law of conservation of momentum states that not just in any collision, but in any isolated system, the total momentum, the sum of the total momentum stays constant. So even if there is no collision, but this bullet is propelling the bullet forward, or in a different situation you might be pushing a football forward, even in those situations the total momentum remains conserved or remains constant. So let us first of all find the total momentum before the bullet is shot. So the total momentum in this case is, well, the momentum of this gun and the momentum of the bullet. So the momentum of the gun is its mass, 4 kg, times its velocity. Well, the gun is stationary, therefore its velocity is 0. The momentum of the bullet is its mass, 1 kg, times its velocity, which in this case is 0. And if we add them, well, 4 into 0 is 0, plus 1 into 0 is 0, and 0 plus 0 is also 0. And that makes sense. Well, there is nothing moving, neither the gun nor the bullet, and therefore the total momentum is 0 kg meter per second. So we know the total momentum before the collision is 0 kg meter per second. Now let us see what happens after the collision, or after the bullet is shot. So we just saw right now that when the bullet was shot, the bullet was moving in this direction with let's say the bullet was shot at 20 meters per second. So the bullet is moving in that direction with the velocity of 20 meters per second. The gun, as a result, moves in that direction, or recoils in that direction, in this direction, with some velocity. Let's say that is v meters per second, and it is the value of v that we are supposed to find out, because this is the velocity of recoil. Now, first of all, why does recoil happen? Well, recoil is the simple result of Newton's third law, which says that for every action force there is an equal and opposite reaction force. In this case, the gun has applied some force on the bullet, as a result the bullet is moving in that direction, but due to Newton's third law, the bullet has applied an equal and opposite force on the gun, and because it is an equal force and an opposite force, therefore the force acts in that direction and it pushes the gun in that direction. Obviously remember, the force is equal, not the velocity, and therefore, so you might be tempted to say that the gun should move at 20 meters per second in that direction, but remember, the force is equal, not the velocity. So to find this velocity, we need to use the law of conservation of momentum. Why is the velocity different? Well, because the masses are different. So a small force on this small bullet would cause a large acceleration and hence a large velocity, whereas the same force on a large gun like this, which weighs 4 kgs, would not bring that large change in a change in velocity or that large in acceleration. So for now, let us calculate the momentum in this scenario, which is the scenario after the bullet has been shot. So what is the momentum of this gun? Well, the mass of the gun was 4 kgs, so it's 4 times its velocity, which is v. So that is the momentum of this gun after the shot, plus what is the momentum of this bullet? Well, the mass of the bullet is 1 kgs, we remember that, and the velocity of that bullet is 20 meters per second. So now I can simply multiply these two. Wait, I'll just shift it here. So I'll just keep this value here. So this was the total momentum before the collision, and now if I multiply this, I get 4 times v plus 1 into 20 is 20 equals, well, it should be 0. Okay, so now let me just shift the 20 on that side and I get 40v equals minus 20, and if I shift the 4 there, I can simply write it on that side this way, and 20 divided by 4, well, I get v equals minus 5, because 20 by 4 is 5, right, and 5 meters per second. So the, okay, you cannot see it, wait, so the velocity after the collision is minus 5 meters per second. So this is the velocity of recoil. And why is it minus? Well, because it is in this opposite direction. So the bullet was in that direction, the positive direction, and because the gun recoils in the opposite direction, therefore we have the minus to signify that. And obviously it is slower than the bullet because it is much heavier than the bullet, and the same amount of force produces a smaller acceleration and therefore a smaller final velocity. And so that is how you calculate the velocity of recoil. And the main thing to learn here is the approach. So if I quickly review the approach here, so what should your approach be? The approach in such question is very simple. First of all, if you understand the question, what is the question trying to ask me? Well, in this case, we know that the question involves the velocity of the gun, and we had been given the mass of the two objects, and there was a collision happening, or there was a change in momentum happening. So whenever such things are given, you may guess that it is easy to guess that law of conservation of momentum must be involved, because the momentum is being changed, and you know the momentum of the bullet before and after the collision, and you know the momentum of the gun before the collision. So it is easy to find the momentum of the gun after the collision by using the law of conservation of momentum. To start off, first of all, write the expression for the law of conservation of momentum, which says that the total momentum before the collision, so let that be total P, let's say initial, equals total P final, or after the collision. Now what is the total P initial? It is the momentum of this plus the momentum of this. So just write that in terms of variables: mass of the gun times velocity of the gun plus let that be v1 m1 v1, and mass of the, let's say that's u, just to differentiate it, m1 u1, and mass of the bullet m2, and velocity of the bullet, initial velocity of the bullet, okay, u2. So it's u1 here, so I won't write that. Okay, so here are the initial momentum of the gun, the initial momentum of the bullet equals the total final momentum, which is the final momentum of the gun, which is m1, mass of the gun, times final velocity of the gun v1 plus m2 and multiplied by v2, which is the final velocity of the bullet. So this is the expression for the law of conservation of momentum, and now you can simply put in the values. So if you want to, if you are comfortable, you may start solving for the unknown variable, which in this case is v1 with the final velocity of the gun. But if you are still uncomfortable with variables, you can directly put in the values. So you can put in the mass of the gun, the initial velocity of the gun, the mass of the bullet, the initial velocity of the bullet, and you can put in all the known variables and then start solving for the unknown variable. But it is very important that you write the expression first and then input the variables, and you have to realize what is the initial velocity, what is the final velocity, and you have to understand the situation before you start applying the formula. So please follow this approach or any other approach that seems logical to you, but it should make sense. So please do not apply this formula without using your mind and without understanding the situation before applying the formula. That's it.